In this video I want to discuss a little bit about power, what it is, and a couple of example problems. So power is just the rate at which work is done or energy is used. So anytime we talk about the idea of a rate, we're comparing how much of a particular value you have over a period of time. And so power, which is just a capital P, is equal to our work divided by time, or power is equal to the energy that you use over time. So whether you're talking about mechanical transfer of energy or just energy being used in various forms, but just the rate at which it's used divided by time. So if we had a situation, a little example here, say we got a wagon. Alright, someone pulls this wagon along, and in doing so does about 25,000 joules of work. Let's say maybe that takes a time of 12 seconds. If you want to find the power that the person had in doing this work, you just simply plug this into our equation of work, 25,000 joules, divided by the time, 12 seconds. So that'll give us a power of about 2,083 joules per second. So we have our power of 2,083 joules per second. And again, as our units keep getting more and more complicated, we're combining more and more units, we just keep naming them after different people. And so a joule per second is named after a gentleman last name Watt. You may have heard of Watt or light bulbs, maybe speakers or power amplifiers, things like that. So Watt is just a capital W in our units there. So power then is just 2,083 watts. So that's how much power we had in pulling that wagon in that example there. We could take another situation. We could say we've got someone over here and you have on a pair of headphones like that. Let's say those headphones have a power rating of 1 milliwatt. That's pretty common among headphones, power of 1 milliwatt. And let's say you want to listen to a song that's about 4 minutes long. Alright, so a 4-minute song and power rating of about 1 milliwatt here. So the question is then, how much energy, how much energy would that use during that time? So we just go back to our power idea again here. Right, so power is 1 milliwatt, and that equals the amount of energy that we're looking for over our time of 4 minutes. So now we need to kind of look at the actual units we have going on here. We're talking about things in terms of watts. Right, we have seconds in here, joules per second. So we need to take our milliwatts here, we need to make it into just watts themselves. And so milli just means 1/1000th, right? And so from your knowledge of the metric system, we just want to move this decimal point 3 places, 1, 2, 3, and so we get a value of 0.001 watts, and that's our energy divided by that 4 minutes. But as we see in the units here, we should have joules per second. So we're talking about watts, that's a joule per second. So we need to change that 4 minutes into seconds. And so we just do a basic little dimensional analysis. Take those 4 minutes, multiply it. I'm going to put the minutes on the bottom, so those will cancel out. We're going to convert those into seconds. So we know 1 minute is 60 seconds. Those minutes will cancel out, and that gives us about 240 seconds. So we come back over here, 240 seconds. Let me make that a little bit. 240 seconds. Alright, so now we just want to go through algebra. Let's just cross multiply. So my energy is equal to 1,000th of a watt times 240 seconds, and that equals about 0.24 watts times seconds. So remember what a watt is: joule per second times seconds. Seconds cancel out and we get joules. So this is 0.24 joules. So you listen to your song on your headphones with a rating of about 1 milliwatt for 4 minutes there. It's about 0.24 joules, really not a lot of energy overall. More energy involved in the player actually producing the music and playing it and running all the files and everything than the actual headphones themselves, what they're using here. Alright, so a couple examples of finding power or using power to find energy in some different situations there.